All right, on page 187, I'm going to title this the change of base formula. Change of base formula. So my first example, if you were told to evaluate log base 81 of 27. So the way that I taught you how to do it is to rewrite it as an equation. So basically set it equal to y. And then write it as an exponential equation. So remember we do that little Snell method thing. 81 raised up to the y equals 27. And then we have to try to write both sides with the same base. Now these numbers, can anybody think of what could I use for 81 and 27 where they would have the same base? Well, 9 squared is 81, but 9 raised to the what's 27? Well, you're thinking 9 times 3 is 27, but if we do 9 raised up to the third power, that's 729, right? So remember, it's an exponent, you're not multiplying. Or are you saying, what were you saying? Base of 3? Or are you saying 9 raised to the third? Thinking base of 3? Okay, I'm sorry, I took it, I thought you were saying if this was third power. Base of 3, because we can write 81 and 27 both with a base of 3, okay? 27 with a base of 3 would be 3 to the third power. 3 times 3 times 3 is 27. 81 is 3 to the fourth power. 3 times 3 times 3 times 3. Just double check in your calculator. Yes, 3 to the fourth power gives you 81. Okay, but 81 already had an exponent of y, okay? So our exponent has another exponent. And that's okay. But we usually, on the last examples that we did, we would say, okay, well, y equals 3. Well, this time, if you have a power to a power, you can multiply those together. So you won't just say y equals 3, you will say 4y equals 3. And then what do you think we do? Divide by 4. So y equals 3/4. That means 81 raised up to the 3/4 power gives me 27. Let me just see if that's true. 81 raised up, I'm going to have to either put that in as a decimal. If I use a fraction, I'll have to use parentheses, otherwise it won't evaluate it correctly. So 3 divided by 4, and that is 27, so that's true. Or I could do 81 raised up to the decimal form, 0.75, same thing. So really it's the same thing, it's just you had that power to a power right there, okay? But not every problem that you're gonna get, you're not gonna be able to write it where it has the same base, okay? That does not always work. All of the problems that we've done so far, you've been able to write with the same base, okay? So sometimes you actually do have to use a calculator to evaluate a logarithm. So I'm going to show you how to do that today. First, we're going to write a little something. The calculator will evaluate logarithms but only logarithms that have a base of 10. Remember last class we talked about common logarithms? Common logarithms have a base of 10. If your base is not written, it's an implied base of 10. So when you see the log button on your calculator, right here, I have a log button, that's assuming you have a base of 10. If I wanted to evaluate log base 81 of 27, I can't use that button unless I use the change of base formula, which is what I'm getting ready to show you. If you are evaluating a logarithm, that has a base other than 10, you can enter it into your calculator using the change of base formula. So, for example, if I had the same problem as I had above, log base 81 of 27, and I wanted to evaluate it in the calculator. Calculator only does a base of 10. So I will convert this to the change of base formula. It's actually very simple. So the change of base formula I would take the log of 27. Notice I'm not writing a base, so that's an implied 10, which is a common logarithm, divided by the log of 81, also having a base of 10. So in your calculator, and this is only on a TI-84, okay? What you would do is you would say, you would hit the log button, it opens a parenthesis for you, and you then hit log 27. You got to do the close parenthesis. You have to do the close parenthesis. You hit the division sign. 81. Whoops. Not 81 yet. Log 81. And then enter. If you have like a TI-30XA, what you used in geometry, you know how you always put the number in first? So if you have one of those, I could probably help you figure out to see how you would do a change of base formula. But on the graphing calculator, that's what you would do. It's imperative that you put the log of 27, that's got to be your numerator. The base has to be your denominator. If you put it in backwards, that's the way that it's going to enter it into the calculator, okay? So you put log of 27 divided by the log of 81. So if you have a calculator on your desk, I want you to enter this with me, right? So here's my log button down the left-hand side. So I do log 27. You have to close the parentheses. Divided by log of 81, close parentheses. I don't think you have to close the parentheses on the denominator. I think it'll still do it. We can try it. Enter, and it gives you the decimal form 0.75. You can also have your calculator change it to a fraction. To do that, I did log of 27 divided by log of 81. It gave me a decimal. Sorry, you can't see that. If you go up and hit the math key, option, you see how you fraction, FRAC's for fraction. If you hit option 1 and it comes up like that, hit enter again and it will convert that last answer to a fraction. But hopefully we know that 0.75 is the same thing as 3/4, but just in case. And there you go. Now really, when we have problems that are easy to write as the same base, we don't need a calculator for that. We can do that by hand. And the reason I don't just show you the calculator method to begin with is because a lot of times on these tests you have to take, you'll have a calculator part and you'll have a non-calculator part. So if you can evaluate a logarithm and write them as the same base, that's going to be on non-calculator days. You've got to know how to do that without the calculator, correct? But on calculator day, you can just do it really quick with your calculator, as long as you know how to enter it correctly. What goes in the numerator, what goes in the denominator. All right, so page 188. I'm going to give you 8 problems for you to enter on the calculator on your own, just so you have the practice of putting it in there and making sure. Now, y'all know I only have like 24 calculators and I have 30 of you. So if the person in front of you or behind you, y'all might have to do it together. But make sure both people get a chance to work the calculator. Otherwise, you're not going to remember how to put it in there. Okay? It is a good idea to get your own graphing calculator. If you're going into pre-algebra next year, you are required to have a graphing calculator. It's required. If you don't have it, you don't take pre-calculus. So this summer, you might want to watch for sales, because they'll go down to about $90. That's about the cheapest I've ever seen it. And then at the height of the season, you're going to see them more like $120, $130. So if you're going to college, you definitely have to have a graphing calculator. Don't even try to go to math classes in college and not have one. You've got to. Even if you're going to probability and statistics, it's a good idea to have your own, and you're probably going to college anyway, so might as well go ahead and get it. So I want you to do these on your own so you have the practice of entering them. Go ahead and do those on your own. Notice the directions do say round to the nearest thousandths place. Are you finished? Are you finished? You finish first. When you finish up, put the answers up on the board. You can make sure that you entered it correctly. If you did not put that parentheses before you push division, your answer will not, you will not get the same thing that I did. Does anybody have questions about those? Everybody get them entered correctly? Get the same thing I did? Okay, good. The change of base formula is especially helpful when it isn't possible to write both sides of the equation with the same base. And in parentheses, I put when written as an exponential equation. So like none of these examples, I don't believe any of them, if you went and wrote it as an exponential equation and tried to write it with the same base, both sides, none of them you could write with the same base, okay? So we kind of need the calculator for problems like the ones that you just did. Everybody cool? All right, so on the next couple of pages, I'm going to show you how to solve equations. Using logarithms, change of base, and all that stuff. So on page 189, I know I wasted a lot of space on that page. Title is Exponential and Logarithmic Equations. Exponential and logarithmic equations. Any equation that includes a variable in the exponent is called an exponential equation. It's when you switch the x and the y, then that's a logarithm, because the logarithm is the inverse of an exponential equation, okay? So if I asked you to solve 16 raised up to the 3x equals 8. I'm going to show you two different ways to solve it. Right now, that's an exponential equation, and can we write 16 and 8 with the same base? Yeah. Let's see. We know 2 to the first is 2, 2 squared is 4, 2 cubed is 8, so we can write 8 as 2 cubed. 2 to the fourth is 16, so for 16 we'll write it as 2 to the fourth. But 16 already had an exponent, so you can't forget about the exponent. So is x equal to 3? No, because if I substituted a 3 back in, 3 times 3 is 9, 16 to the 9th power is not 8, right? So we have to remember, when my exponent already had an exponent, when you go to set these two equal to each other, a power to a power, you multiply those together. So 4 times 3x gives me 12x, and you set 12x equal to 3. If our bases are equal, then our exponents must be equal. But if you've got two exponents, if your exponent has an exponent, multiply those together, then you can set it equal to the other side. Then what would I do? Divide by 12. X equals 3/12, which reduces to 1/4, or you could say 0.25. Now I'm going to show you another way to solve the same problem. So another way, what you're going to do is you're going to rewrite as a logarithmic equation. Now to do this method, to rewrite it as a logarithm and solve it that way, that's going to be more helpful to you when you have a problem that you can't write with the same base, okay? Because if you could, then I would just solve it that way. But this is more helpful when you cannot do that. So as a logarithm, you know that would be log base what? Log base 16 of 3x equals 8. Log base 16 of 3x equals 8. And then we know to solve that 16 raised to the 8th power equals 3x, right? So we're going to rewrite that as 16 No, we're not. We're not doing that. My bad. I got ahead of myself. What we're going to do is we're going to use the change of base formula. I wrote this wrong, didn't I? The exponent should be over here, and the 8 should be here. Yes, exponent always goes on the other side, because remember 16 raised to the 3x equals that. So I'm sorry, I made a total mistake. Should have been log base 16 of 8 equals 3x. So I'm going to use my calculator to do the change of base formula on log base 16 of 8, okay? So I said use the calculator and the change of base formula to evaluate log base 16 of 8. So in my calculator, I'll do log of, what do I put in first? Log of 8, close parentheses, divided by log of 16, and I get 0.75. So the left side of my equation is equivalent to 0.75. And we know that equals 3x. Then what would I do? Divide by 3. And x would equal 0.25. Same thing as I got above, just a different way to do it. So take your equation, rewrite it in logarithmic form, just evaluate this side with the logarithm in your calculator using change of base, set it equal to the other side, and solve for the variable. show you another one. If I had 27 raised to the 3x equals 81. Now, I know I can write 27 and 81 with a base of 3, so I could totally do it that way, but I want you to do it to write using a logarithm, okay? So to rewrite that as a logarithm, that would be log base 27 of 81 equals 3x. The exponent always goes on the other side, because remember it's 27 raised to 3x equals 81. And then what am I going to do? I'm going to do the change of base formula just on the left side. So in my calculator, log of 81, close parentheses, divided by log of 27 equals, I'm going to have to round here. I don't want to round too soon. I don't want to throw my answer off, so I took it out 4 places. Then what? Divide by 3. X equals, approximately, we'll go with 0.444. So if I did that correctly, 27 raised up to the 3 times 0.444 should give me 81. Now I'm rounding in my calculator, so my answer is going to be slightly off when I put it in, because I've got a repeating decimal. 27 raised up, open parentheses, 3 times, I'll put it in my calculator a bunch of times, and I get 80.99996. Would you say that I did it correctly? It's not exactly 81, but I rounded here, right? It's a repeating decimal, and that rounds up to 81, so we probably did it correctly. Any questions on that? All right, I'm going to do several examples on the next page. But I only have one more page, but it is several examples. So page 190. Solve each equation. On the first one, we have 8 raised to the 2x equals 32. I'm going to write that as a logarithm. So that would be log base 8 of 32 equals 2x. I use change of base to evaluate log base 32 of 8 first. So it's log of 32, close parentheses, divided by log of 8. And I get, I'm going to go with 1.667 equals 2x. Now what? Divide by 2. And x is approximately 0.83 repeating. So 8 raised up to the 2 times 0.833333 should give me 32. Questions on that one? Example 2, 4 raised up to the x power, and then I have a minus 5 that's not in the exponent, equals 12. Okay, before I can write that as an exponent, this has to be in an exponential form, okay? So if you want to make yourself a little note, I said must get in exponential form before writing in logarithmic form. must get an exponential form before writing in logarithmic form. You need a base with an exponent set equal to some number, okay? I've got a base with an exponent and then a minus 5 set equal to a number. What do you think I would do to get an exponential form? I would add 5 to both sides. So that would give me 4 raised to the x equals 17. Now this is a good example. Can I write 4 and 17 with the same base? No. So if I wanted to solve it that way, I can't. Because 17 can't be written with a base of 4 or even a base of 2, because I could write 4 with a base of 2 or a base of 4, but 17 couldn't be written with either. So I would have to use logarithms to solve this one, okay? Or a lot of guessing. So in logarithmic form, that's going to be log base 4 of 17 equals x. I'll use a change of base formula on the left side. So log of 17, close parentheses, divided by log of 4. And I get 2.04 approximately. I'll go with 2.044 equals x. And x is already solved for. I don't need to divide by anything. I'm going to use approximately because that was rounded. What if I gave you this example and asked you to solve it? Log of x equals 2. What's my base? 10. It's 10. I have a base of 10. It's implied as a common logarithm. So do we know what x is equal to? What is it? 10 squared equals 100, right? So I would write this. This one we can't use a change of base formula because we have a variable there, okay? So I would say I would change that to exponential. 10 raised to the second power equals x. This is a variable. We can simplify 10 squared to get 100. So that's how you would solve that one. If I had log of 4x equals -1. What's my base? 10. Again, I can't use change of base on this one because I have a variable 4x. I can't put log of 4x divided by log of 10. I can only do it if the variable's on the other side. So to solve this problem, I'll have to write it as an exponential equation, which is 10 raised to the -1 equals 4x. Hold on, over here. 10 raised to the -1 is the same thing as what? One-tenth, right? 10 to the first, it'll be 10, but because it's negative, it's 1/10. So I'd probably just change that to a decimal. 1 divided by 10 is 0.1. You could have just put it in your calculator to begin with. 10 raised up to the open parentheses -1 and got 0.1. So I would change that to 1/10 as a decimal equals 4x. And then of course we would divide by 4. Is x equal to 1/4? No, that's 1/10 divided by 4. 1/10 divided by 4 is 0.025. 25 thousandths. So you've got to look at each problem differently. Do I want to convert this to a logarithm? Can I write it with the same base? Or can I use change of base formula to solve it? Just depends on where that variable is, really. And if you can write both sides with the same base. Example 5, log of, open parentheses, x minus 25, close parentheses, equals 2. Again, what's my base? 10. I've got a variable over here with a logarithm. I can't use change of base. So I'm going to have to rewrite it as an exponent, which that would be 10 squared equals x minus 25. Now what? Do I want to do that yet, or want to take an exponent? Exponent. I mean, I could add 25, but I would probably do the exponent yet. 10 squared is 100 equals x minus 25. And then add 25. So you would get 125 equals x. So would that make sense? 125 minus 25 would be 100, right? Is 10 squared 100? Yeah, so that would make sense. Example 5. Y'all stop me if you have a question. Example, what? Oh, I did 2 fours. Sorry, last one was 5. This one is 6. On this one, I have 2 log of x. That means 2 times the log of x. 2 times the log of x equals 2. Now, I can't convert this to an exponential equation until I get rid of this 2. If 2 is being multiplied by the log of x, and I need to get rid of it, what would I do? Divide both sides by 2. So that gives me log of x equals 1. What's my base? 10. I've got a variable over here with a log, so I can't use change of base, so I'm going to rewrite it as an exponential equation. So that would be 10 to the first power equals x. So what's x equal? 10. Number 7. Log of x minus log of 4 equals 3. And you're like, what? But don't panic. Could I use the change of base on log of x? No, because I got a variable with a log, right? Could I use the change of base with the log of 4? Yeah, because my base is 10. I'm taking log base 10 of 4. I've got numbers in both spots, so I can use the change of base on that, turn it to a number, and then go from there. So I'm going to make myself a little note. Change of base. So log base 4, log of 4, I would do log 4. And you don't even have to do divide by log of 10 because it's a common logarithm and your calculator already does common logarithms. But if you forgot that and you would get the same thing. Log of 4 divided by log of 10, you get the same thing because your calculator automatically does a base of 10. Okay, so I'm going to rewrite this as log of x minus, I'll round that to 0.602 equals 3. Now what do you think we should do? Add 0.602 So when I do that, now I have log of x equals 3.602. And we already said you can't do the change of base on log of x because it's of the variable, correct? So what would I do to figure out what x is equal to? Anyone? Yep, write it as an exponential equation, right? We know the base is 10. So 10 raised up to the 3.602 will give me my x. And then, of course, I can just write that in the calculator, or put it in the calculator. And x is equal to approximately 3,999.447. Let me do one more like that, and then I will give you your assignment. Does anybody have questions on that one? Okay. I don't have much room, so I'm going to have to write small. Example 8 says 2 log x minus the log of 4 equals 2. So the first thing I did, instead of dividing by 2, because you're going to be like, well, what part do I divide by 2? Before I did that, I went ahead and turned the log of 4 into a decimal, which I already know from the last example, log of 4 is equivalent to 0.602. So I'm going to do that first. Then I'll move the negative 0.602, I'll add it to the other sides, and then I'll worry about dividing by the 2. So once you get to that point, before you can write it as an exponential equation, we have to get rid of this 2 times the log of x. We don't want the 2. So we will divide both sides by 2. Then we have log of x equals 1.301. Remember, we want to solve for x, not the log of x. So I have not solved for x yet. I still have to rewrite this as an exponential equation. We know the base is 10. So that's going to be 10 raised up to the 1.301 equals x. I know that's tiny. And so my answer, x is approximately 19.9986. I'm just going to round that up to 20.
What if I put 19.999?
That's fine. Nope. That's more accurate than mine is. So that's fine. Anybody have questions on that? Okay, we'll pause my video and get you your assignment.